Okay, this is 4.9. Admittedly, we've gone over a lot of different ways to solve quadratic formulas. So how do we tell which one to use? How do we know? Well, welcome to 4.9, where we're going to find out. All right, as mentioned in the intro, we're going to start to think about all of these different strategies to solve a quadratic formula and figure out which one is the best choice to use. Now, one of the ways that we have to figure that out is by using this thing called the discriminant. So that's what we're going to talk about. So the discriminant is just a number that we can pull out of an equation, and it gives us some information about like what the solution is going to be. So it's useful to know because then that can help us decide what type of strategy we're going to use. So it is a formula, and this is using standard form, so your ax squared plus bx plus c. But the formula is the discriminant is b squared minus 4ac. So hopefully that looks a little bit familiar. The quadratic formula, this is all the stuff that's under the square root. So the actual discriminant doesn't have the square root in it, but once we solve this kind of formula, which should kind of be fairly easy, you just kind of plug it into your calculator and you get a number. That number can tell you a lot of different things about what the solutions are going to look like. So, for example, if we say that the discriminant is greater than 0, so positive, and it's a perfect square, so we're saying like 4, 9, 16. I had to do some math in my head. So it's positive number and a perfect square. We know that there are two roots or two solutions, and they are going to be rational numbers. So that means that a fraction, maybe, hopefully a whole number because those are easier, but whatever. So let's say it's positive and not a perfect square. So 2, 3, 6, 20, I don't even know because I don't want to. Positive number, not a perfect square. We still know that it has two roots. But if it's not a perfect square, we know that it's going to be irrational. That means that there's most likely going to be a square root in the answer somewhere. So that might help us okay, maybe we should use the quadratic formula or maybe completing the square. Depends on what the equation looks like. So let's say the discriminant, this equation, equals 0. Like it straight up equals 0. There is only one solution to that equation, and it is going to be rational. So again, if you do the discriminant and it equals 0, then you know that there's only going to be one solution and it is going to be rational, which makes sense if you look at the quadratic formula. This whole thing goes to 0, you lose that square root, there's only going to be one. Anyway, so let's say that the discriminant is negative. So if we're, again, kind of referring to the quadratic formula, there is a square root under there. So let's say underneath there is negative. What is that going to mean? It's going to mean that our solutions are going to be imaginary. So they're going to have an I in them, which again makes sense because we got a negative sign under a square root. And again, there will still be two solutions. So the discriminant is a useful tool in helping us decide what strategy to use and what the answer is going to look like. So let's try some examples and see if that helps. All right, so here's some examples. We're going to kind of go through them a little bit quick just because I want you to see that the discriminant is fairly simple and easy to do, and that's why it can help us give us some information. So number one, okay, so we've got A equals 2, B equals 12, and C equals negative 13. All right, no problem. So we're going to plug that in. So we're going to have 12 squared minus 4 times A times C In this, I'm going to plug straight into my calculator. As long as you enter it in correctly, it's fine. I'm going to type in 12 squared, minus 4 times 2 times negative 13. And it's all going to come out to, or it's all going to do the order of operations correctly as long as you enter it into your calculator correctly. So all of that equals 248. So 248, so then I can take the square root, see if it's a perfect root, 248. I get 15 point a bunch of different numbers, 15.74, 8, 0, 1, 5, blah, 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 blah. So from that, I know that we have two solutions, and they're going to be irrational. So I'm going to be dealing with some square roots. Okay, next one. So again, we've got A equals -1, B equals 16, C equals -64. Plug that in. 16, that's not a 6. 16 squared minus 4 times A times C. And go gadget calculator. Minus 4 times -1 times -64 equals 0. So we know that we have one solution, and it is going to be rational. And number 3 equals A, -4 equals A. B equals -10. I did some algebra in my head there because I didn't realize it until after I started writing. So if I were to rewrite this equation, it's going to be -10x plus 84 equals 0. Don't forget to put it in standard form is what I'm saying. And C equals 84. So -10 squared minus 4 times A times C, 10 squared, and yes, I forgot to put the negative, but it's going to go away anyway. 4 times -4 times 84 equals a big number. 1, 4, 4, 4. I'm going to take the square root of that to see if it is a perfect root, and it is. I don't know how I want to write this. So square root, it doesn't equal that. But it is a perfect root, so I'm going to say we have two solutions and they are going to be rational. Last but not least, number 4. A equals 3, B equals 0, because it's not there. C equals 24. So B squared minus 4 times A times C is going to equal -4 times 3 times 24, -288. Oh my gosh, I can't make an 8. 88. So it's negative. Let's see if it is, actually doesn't matter. So it's negative, so it's going to be two solutions, and they are going to be imaginary. So that's how the discriminant can help us decide how to solve these things. Okay, so let's review all of the methods that we have to solve a quadratic formula. Or a quadratic equation. So number 1, we can always graph it, right? So this can be used, I'm kind of looking for like sometimes or always. So you can actually always graph it, but a lot of times and most of the time it's not practical. And if it doesn't have an even integer, then it's not worth doing. So if you graph it on your calculator, like that I would do, and it's like maybe off in Never Neverland, or like it's in between two numbers, then graphing is going to be really, really hard and only going to give you a approximate answer. So it can be used sometimes. and generally it's not practical. I guess I should put that, oops, we'll put that right over there. Sometimes, but generally not practical. It still can be used when roots are integers. Graphing is generally used when you just kind of want to get a sense of what is going on. So especially maybe in the real world when you just kind of want to see a trend, or in science if you have like a trend line, things like that. That's when graphing is going to be useful. So our next idea is factoring. So factoring sometimes works. And it works when the roots are rational. Which we could figure out by using the discriminant. So factoring is actually probably the easiest method, but it only works when the roots are rational, which is why we have the discriminant sometimes. Okay, square roots. So that's when you have, a number here that's squared, and then you square root both sides. So if you remember that part. So square roots work sometimes. It works when there's no b term. So that's like the x term. So if you see an x squared equals a number, that's when square roots, when you're going to square root both sides, that's when that could be useful. So generally, when there is no b term, otherwise known as no x term. So completing the square, that's the one a little bit more complicated, where you're going to add something and then subtract, or add something to one side of the equation, add it to the other, so that you can get a perfect square trinomial, and then you can square root both sides. So completing the square always works, which is nice. Always works, but it is best used when there's no x squared coefficient. So no x squared coefficient. And y'all already know I can't spell that word without checking it. So no x squared coefficient, and it also helps if there is an even b term. Again, the b term is the x term. So no x squared coefficient, so that's that number right there. So as long as there's not a number right there and b is even, completing the square is a good choice. For all other situations, you can always do the quadratic formula. The quadratic formula is generally kind of the hardest, and or it takes the most steps, but it works. It works all the time. You can use it anytime. So there's a lot of people out there that just kind of forget a lot of this stuff and just remember the quadratic formula. It makes extra work, but it's not a wrong strategy. For this chapter, there will be times where I will specifically tell you when to use certain techniques, because I want you to actually have those tools. But worst case scenario, quadratic formula always works. Okay, so let's make some decisions. So we've got these 4 equations on the screen, and we need to decide how we want to solve them. So the first thing I'm going to do is find the discriminant of each, and that's going to kind of help guide my thinking. So if I were to start on the left, so our discriminant is, what is it? B squared minus 4AC And I'm just going to plug all this calculator into my calculator later. This one, b is negative 0. Oh, why is it negative? It's just 0 squared, whatever, I don't care. Minus 4ac, b squared, negative 22 squared, minus 4 times 3, 4ac, 6 squared, b squared, minus 4 times a times c. Okay, go gadget calculator. 9 squared minus 4 times 1 times 21 equals negative 3. So we're going to have 2, it's negative. They're going to be imaginary. I don't care about writing anymore either. Yes, my handwriting is terrible. That's okay. Okay, next one. Got negative 4 times negative 2 times 144 is a big number. Square root of that number is not an even number. So we are going to have 2 irrational values. Okay, equation C, we've got 22 squared minus 4 times 3 times 7, 400. Pretty sure that's a perfect root, but I'm going to double check just in case. Square root of that is 20. So we're going to have 2 rational numbers. And then equation D is what? 6 squared minus 4 times 1 times negative 15 is 96. Is that a perfect root? 96? Nope, didn't think so. So it's still going to be 2 solutions, and they're going to be irrational. Okay, so now using the discriminant, we can make some choices. So down here it says solve each equation using the methods below. You can only use each method once. So we kind of got a little bit of a puzzle here. We've got to match the equation to the best way of solving it. So step 1, this one has 2 solutions that are rational. So that's the one that's going to be able to be factored, hopefully fairly easily. So we're going to put C in the box because that's going to be equation C. And just for now, I'm going to write 3x squared minus 22x plus 7 equals 0 in the box, so don't forget about that later. This next one's square roots. So I'm looking at, I want to say equation B, because just kind of doing some mental math, I can divide both sides by negative 2, and I'm going to have an x squared equals a number, and I can take the square root of that. I'm going to get an imaginary number, but that's fine. So I'm going to put equation B right here, and we'll write that out. Negative 2x squared plus 144 equals 0. So we have used this one and this one. So now I'm looking at equation A and equation D. So my first thing is, okay, so if I'm going to complete the square, which that's down here, but if I'm going to complete the square, I, number 1, don't want any numbers in front of there. Okay, well, neither one of them has it, so I'm good there. But this being even will help me with the completing the square thing, because honestly, it'll help me avoid fractions, because remember, you have to add, you take b divided by 2 and then square it. So if we can avoid fractions, I'm all about that. So we're going to put d down here by completing the square. And that equation is x squared plus 6x minus 15 equals 0. And then the thing that I got left, equation A, quadratic formula that always works. And that is x squared minus 9x plus 21 equals 0. So those are my decisions. Those are my what I would do. And let's get factoring. All right, so my first one is factoring. What I'm going to do is I'm going to take this guy, and if you remember how to factor, we're going to wrap that 3 into the 7. So now I'm going to have x squared minus 22x plus 21 equals 0. So that factors pretty nicely because the factors of 21 can be 1 times 21. And then when they are both subtracted together, they'll give me the negative 22. So I've got x minus 1 times x minus 21 equals 0, which means my answer is x equals 1 and x equals 21. So hopefully you see if you can factor it, it's pretty easy. Oops, except I'm not done yet. So we wrapped the 3 in. Now we got to take the 3 back out. We're going to divide both those by 3. This one has to go to the front because 1 does not divide by 3 evenly. So we're going to have 3x minus 1. And 21 divided by 3 is 7. So we're going to have x 21. Oh my gosh. X minus 7 equals 0. Okay, let's try this again. X equals 7. And 1/3, right? So yeah, we still got a fraction, but we don't have to do any math with it. It's just the answer. So using our square root stuff, we're gonna have x squared equals negative 144. I'm sorry, negative 2x squared. So we divide both sides by negative 2. X squared equals 144 divided by 2. We've got positive 72. I thought there was going to be negative, but that's what I get for estimating. Square root of 72 is not an even number, so we get to play this game. So I'm going to take 72 divided by 2. A, because 2 is my favoriteest number, and B, because it's even. And then 36 is, I'm going to take another 2 out of it. 2 times 18. 18 divided by another 2 is 2 times 9. Okay, so now we've got some perfect squares. We've got that, and we've got that. So that means we can pull a 4, 2 times 2 out. Well, anyway, we are going to square root both problems. I got a little ahead of myself. We're going to square root both sides. So that means we're going to have x equals plus or minus. And here's where that tree, that factoring tree helps. We're going to rewrite square root of 72 into square root of 4 times square root of 9 times square root of 2. So here's my 4, here's my 2, here's my 9. So then that turns into plus or minus 2 times 3 square root of 2 equals plus or minus 6 square root of 2. Yes, I took kind of a longer way around that, but I like doing that a little bit better because I like smaller numbers. It makes me happy. If you saw that all of these together is equal to 36, you can pull that right out. Square root of 36 is 6. Also works. Either method is fine. Completing the square is everybody's favorite. Let me see if I remember how to do it. Just kidding, I remember how to do it. X squared plus 6x equals 15. So I'm getting rid of that 15. I'm just kind of storing it on the other side. And got to do my little research to figure out what number to add. So I'm going to take 6 divided by 2. We're going to square it. 6 divided by 2 is 3. 3 squared is 9. So now we're going to have x squared plus 6x plus 9 equals 15 plus 9. So then we can factor this now, which turns into, just kidding, x plus 3 squared. We're gonna combine these two terms. 24, right? Okay, so then from there we can square root both sides. X plus 3 equals plus or minus square root of 24. Does that equal a thing? Don't think so. It does not. So I'm going to make my little factor tree of 24 just to see what I can pull out of it. 2 times 6, and then I don't think I can pull anything else out of 6. So I can pull a 4 out of 24, and I'm going to move the 3 over. So we got x equals negative 3 plus or minus. When we pull a 4, 24 divided by 4, is 6. So when we pull the 4 out of the square root, when it comes out, square root of 4 is 2. And that's our answer. Okay, last but not least, the quadratic formula. So I don't even remember, so I'm just going to write it here. Negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so now we can plug that in. Negative b, there's no negative sign, plus or minus square root of b squared minus 4 times a times c all over 2a. Oh, let's see. Let's move this guy out of the way. So that's going to equal just a regular 9 because a negative of negative plus or minus square root of 81 minus 4 times 21, 84, all over a was 1, all over 2. So now we got 81 minus 84. I don't know why I just plugged it in the calculator. I knew that one off the top of my head. Square root of negative 3 all over 2. Now we can't leave it like that. We do have to turn it into its imaginary number. But once we get there, that's our answer. So again, 4 different ways of essentially solving a similar type of problem. But the skill here that we're learning is more so like being able to identify what is the best technique in order to solve a problem. And that's kind of the takeaway of how we're doing all of this stuff, or why we're doing all of this stuff. So we'll talk more about this tomorrow or today or whenever it is that you are actually watching this video. But either way, I will see you in class.